Assalamualaikum and good day. In this video, we will be focusing on allotropy transformation. This is the third part of iron-iron carbide system videos. The first part we covered on solid phases. The second part we covered on phase transformation reactions. And later on, in the last part, we will cover on microstructural changes in other videos. So, what it is mean by allotropic transformation? A material that can exist in more than one lattice structure. It is depending on temperature, either heating or cooling. An allotropic material is able to exist in two or more forms having various properties without change in chemical composition. It means that upon heating or cooling, the material will change in lattice structure, for example from BCC to FCC, without change in chemical composition. Without change in chemical composition means if you have 2% of carbon in iron, the composition of carbon will be maintained at 2% even the lattice structure change from BCC to FCC or vice versa. Upon heating, pure iron experience two changes in crystal structure. Pure iron means at 100% iron and 0% carbon in our iron-iron carbide phase diagram. It is located over here. At this point, the carbon content is 0%. Only pure iron available. So at room temperature, it exists as ferrite or alpha iron. The lattice structure is in BCC or body-centered cubic. When we heat it to 912 degrees Celsius, it experiences an allotropic transformation to austenite, or we also call it as gamma iron, with lattice structure of FCC. What does it mean is, at first, at room temperature, it is in BCC form. The microstructure is alpha ferrite. And then, after 912 degrees Celsius, the microstructure changed into austenite or gamma iron. This lattice structure changed from BCC to FCC. The changes of lattice structure will not affecting the chemical composition. It still remains as 100% iron and 0% carbon. Only the lattice structure change due to heating process. The heating goes up more than 912 degrees Celsius. At 1394 degrees Celsius, austenite revert back to BCC called delta ferrite. So the note tell you after we heating up more than 1394 degrees Celsius at this point, the FCC austenite change into BCC delta ferrite over here, BCC. This is the example of allotropic transformation, where with the same chemical composition, the lattice structure and the microstructure change from BCC in alpha ferrite into FCC in austenite, and then later on it transforms again into BCC as delta ferrite. Upon cooling, the allotropy of iron change from delta iron as in BCC lattice structure into austenite in terms of FCC lattice structure, and then when we further cool it down, it changes into alpha iron or ferrite, which is in BCC lattice structure. If we start from top until bottom, it is cooling process. When we start at low temperature until top, it is heating process. But the allotropy change for iron is still the same. Below 912 degrees Celsius, the ferrite is formed as beta iron or ferrite. We call it as beta because it forms a non-magnetic BCC. Later on, it formed alpha iron or ferrite. We call it alpha. It is magnetic BCC. But usually below 912, we only use alpha iron or ferrite term only. Other important info is above 1538 degrees Celsius, the iron will be melt, so there is no lattice structure formed because it is in liquid state or liquid phase. That's a little brief on allotropic transformation in this part 3 video. Later on in part 4, we will look at microstructural changes for iron-iron carbide system. Till we meet again, thank you, have a good day.